Good afternoon, everyone, and welcome to lecture number 6. And we still now in network layer, and we are going to talk more about the subnetting. First, let's talk about the network address. What is network address? Which it is a very important concept in IP addressing, and this network address, when an organization is given a block of addresses, it's up to the organization's need to allocate the addresses to the devices or to the hosts to be connected to the internet. Let's say in this organization we have some computers, some routers, some printers, or anything. So this organization is free to allocate those addresses which is inside that block to the given hosts inside the organization. So the very important thing here is the first address. The first address in that block is called the network address, and it defines the organization network. So it defines the organization itself to the rest of the world. So anyone inside or any other computer or any other host outside this organization is going to recognize this organization by the first address. So in this network configuration example, we have the rest of the internet, and this is our organization. Our organization has been given 32 addresses because that the end is 28, and 32 minus 28 is going to be 4. And so sorry, 16 addresses, because the 32 minus 28 is going to be 40 to power 4 is going to be 16. So it starts from 32 up to 30 up to 47, which is going to be 32 different addresses. And the first address, which is this one, is going to be called the network address. It's going to be going to be assigned to the network address, and the rest of the addresses are going to be given to the hosts and one side of the IP address. And this is very important here because all the messages which are going to be received to this network or sent out from the network is going to be received through that IP address, and this organization doesn't know anything about that. So but one of the IP addresses must be given to the other side of the router. So the organization network is connected to the internet via router, which was in the previous slide. And we said that each router has two different addresses. One belongs to the granted block, and the other belongs to the network that is the other side of the router. So the rest of the internet is going to communicate with our organization with using the other side of the network of the router. So we call the second address, which is connected to the rest of the internet, xyz.t/, and because you don't know anything about it. So this IP address is going to be used in order to communicate with the rest of the internet. And as we said, that the first address, which is going to be that one, is not going to be given to any device inside our organization. It defines our network. So the rest of the internet is going to communicate with us using the first address. So let's define the hierarchy. What is hierarchy? As the country codes, the IP address has hierarchy as well. So this is, for example, the telephone in the network in North America. We have 048, which is area code, and A60, which is exchange office, and A902, which is going to be defining the subscriber. And same as this one, the IP address is going to have its own hierarchy. And we have two-level hierarchy, which we don't have any subnetting. So any IP address can define only two levels of hierarchy when it's not subnetted. The first one, which is n leftmost bits, we are going to define the network or the organization network. And the 32 minus that n is going to define the host or the particular device inside our network. And there are two important terms or two common terms which are used inside the IP addresses. They are prefix and the suffix. The part of the address that defines the network is called the prefix, which is this one. This one is going to be called the network prefix. And the part that defines the host is called the suffix. And this one is going to be the suffix. And the prefix, which is the network address, is going to be the same for all the devices which are inside the current network or the current organization network, while the suffix is going to be changed for each individual device. Furthermore, we may have three levels of hierarchy, which is called subnetting. So, for example, an organization is going to be granted a large block of addresses, and this organization may want to further divide those addresses between more subnets. For example, we have the highest level, which is 16 addresses, and these 16 addresses is not going to be given directly to the hosts or the devices. It's going to be divided to two more or three more subnets, and through those subnets, the devices or the hosts are going to communicate to the rest of the world. So this is going to be called the three levels of hierarchy, while the rest of the world still see the organization as one entity. However, internally inside the network or inside the organization, there are several subnets. So all messages are sent to the router added that connects to the organization to the rest of the internet. That means any message through this organization or through any device which is connected to any subnet in this organization is going to be sent through that router. And even when a message comes from outside of the network organization is going to be given to that router, and that router is going to deliver the message into an appropriate subnet, and then through the subnet the message is going to be given to the to the particular device or the host inside the network. So to do this, the organization needs to create small subblocks of addresses, which is called subnets, and it is assigned to a specific subnet. So any subnetwork has its own subnet. So in this case, the organization has its own mask, and each subnet must also have its own mask. So the total organization, the whole organization has a mask. However, each subnet inside this organization has its own mask. Here we have an example, and we suppose an organization is given the block of address which contains 64 addresses, and this is going to be an address inside that block. And this organization has three different offices. That means it has three different subnets, and it needs to divide the address into those three subblocks of 32. One of them is going to be 32 addresses, and the second one is going to be 16, and the last one, which is the third one, is going to be 16 addresses. So we can find the new masks by following arguments. So the first one is 32 addresses. So we can say that 2 to the power 5 is going to be 32. So we can easily say 2 to the power 32 minus n is going to be, how much is going to be? 27. So the n of the first subnet is going to be 27. However, for the second one, which has 16 addresses, 32 minus 2 to the power 32 minus n2, which is going to be 28 addresses. 2 to the power 32 minus n2, 28, is going to be 4 to the power 4 is going to be 16. That's how we can find the n of the second address. And for the third subnet, we can do the same. So it's going to be 28. First, we could find easily the n of each subnetwork. And this means we could easily find the 27 for the first subnet, 28 and 28 for the second and third subnet, while the organization mask is being 26, which was given there. So in the next slide, we are going to see the scenario of the network configuration of this block. So this is an overview of the solution, and we are going to solve it step by step in the upcoming slides. So this is XYZT/N, which is communicating our network to the rest of the internet, and this is the first address of the block, which is being given to the whole network inside that organization. And inside this organization, we have three subnets, 1, 2, and 3. And the first subnet has 32 addresses. We start from 1 and ends with 31. And one address is going to be given to the side of the router. And this one has 16 addresses. One of them is going to be given to the side of the router, and one of them is going to be the backbone, and the others are going to be distributed over the whole hosts or devices inside the second subnet. It starts from 33 up to 47, and the last one starts from the 48 and ends in 63. So the 48 is going to be given to this one, and one of the addresses is going to be given to the side of the router in order to recognize this subnet, and the other addresses are going to be given to the devices inside that subnet. Okay, let's see how each subnet gets its own mask. So in order to find out the subnet of the first, the subnet mask of the first subnet, we are going to choose an IP address, which currently is going to be this one with the n of 27, and 32 minus 27 is going to be 5. So the 5 rightmost bits are going to be 0 and ending with the binary notation of that IP address. When we did that, we will get this subnet. This is going to be the subnet of the first. This is going to be the mask, sorry, for the first subnet, which we are translating into decimal. It's going to be 17, 12, 14, 0. How about the second one? So we choose this one, 17, 12, 14, 45, which is going to be an IP address in the second subnet, and the n is 28. So 32 minus 28 is going to be 4. So the four rightmost bits are going to be 0 and ending with that IP address with the binary notation, and we will get this one. This is going to be the subnet of the mask of the second subnet. And the third one, we are going to choose that one, and then again ending with the mask, and then the subnet mask is going to be this one. So it's going to be the starting address of the third subnet. So if you want to check by applying the mask of the network by 626, so to any address inside the total organization addresses, we will get this one, which is going to be called the network address. So in those 3-level hierarchies, the first subnet has 26 plus 1, which recognizes the subnet prefix, and this one is going to be the network prefix, which was 26. And when we say add 1, it's going to be the first subnet, which was 27. So 27 minus 5 is 32 minus 5 is going to be 27 for the second subnet. And the third subnet, which has only 4 bits for the host address, we could get 28 bits for the network address. So we can say that for this subnet, 27 bits are going to be assigned to the subnet prefix, while 5 bits only is assigned to the host addresses, which is going to be 32 addresses. And for the second and the third subnets, we have 28 bits for the subnet prefix, while 26 bits in all the addresses inside that. Those blocks which belongs to that organization are going to be called the network address, and this one only 4 bits are going to be remain to the host addresses, which are going to be 16 different addresses for the individual hosts or devices. So in this example, we are analyzing the 3-level hierarchy as shown below for this network address, which starts at this one. This is going to be the network address, and then we are going to draw the diagram. This is what's given there, and then the first subnet, which has 32 different addresses, which is going to be 2 to the power 5. So 32 minus 5 is going to be 27, which is going to be the mask of that subnet, and it starts from this one up to that one, from 0 up to 31. While the second one is going to be 16 IP addresses, which is 2 to the power 4. 32 minus 4 is going to be 28 bits, and it starts from that address to that address. While for the third one, we have 16 IP addresses, and 32 minus 4 is going to be 28, and it starts from that address to that address. So 2 to the power 4 is going to be 16. So 48 up to 63 are going to be 16 different addresses, and this is the same as the previous picture. This is how the first subnet, second one, and the third one are going to get the IP addresses inside their network. So we may have more levels of hierarchy, while a large block is going to be divided into small blocks, and furthermore these small blocks are going to be divided into sub blocks, and then through those sub blocks the customers are going to get their own IP addresses. And we can translate this one. National internet service providers are going to distribute the blocks into regional internet service providers, and then these regional ISPs are going to distribute to the local ISPs, and the local ISPs are going to give a block of addresses into the organizations, and the organization can furthermore subdivide their blocks into several subnets. So we can say how addresses are allocated. So the term address allocation means how the blocks are allocated. So the responsibility of the address allocation is given to global authority called the Internet Corporation for Assigned Names and Addresses, ICANN. However, this ICANN does not allocate the addresses to the individual organization or the individual customers. It assigns the large block of addresses to an internet service provider, whether it's going to be a regional or a local or stuff like that. And then through this internet service provider, which is going to be a regional or local, it divides the assigned blocks into smaller sub-blocks, and then these blocks are going to be granted to the organization or the customers. So we can conclude that in this way, ICANN is going to give the blocks into national ISPs, and the national ISPs to the regional ISPs, and to the local ISPs, and the local ISPs are going to give the block of addresses to the organizations, and the organizations are free to to divide or to subdivide the addresses or the block which is being given to it into more subnets. So let's take this example. Any ISP is granted a block of addresses starting with this IP address, which is n is 16. So 32 minus 16 is going to be 16. 2 to the power 16 is going to be 65,536 different addresses. So this ISP needs to distribute these addresses to 3 groups of customers as follows. That means those 65,000 addresses are going to be distributed to 3 different groups of customers. The first group has 64 customers. So it's going to be an organization, 60 different organizations. And each organization needs 20 to 256 addresses, while the second one has 128 customers, and each needs 128 addresses. And the third group has 128 customers, and each needs 64 addresses. So we have been asked to design the subblocks and find out how many addresses are still available after this allocation. So we need to find out what are the IP addresses and how many IP addresses are going to be given to each block. For the first group, each customer needs 256 addresses, and log 256 is going to be 8. That means n is going to be 32 minus 8 is going to be n, which is going to be 24. And the first address is going to be starting from the first address, and then we are going to go through the addresses in order to find out the address of each customer. So the first customer needs 256 addresses, so it starts from 0 up to 255. For the second one, this one is going to be 1, which identifies the second customer, and starts from 0 up to 255, up to the last one, which is going to be 63. 0 up to 63 is going to be 64. So we have 64 different customers, and each customer has 256 addresses. So 64 multiplied by 256 is going to be 16,384 different addresses, which is being given to the first group. For the second group, we have each customer needs 128 addresses, and we have 128 customers as well. So for the addresses, log 2 to 128 is going to be 7. So 32 minus 7 is going to be 25. So as we did in the previous group, 0 up to 63 was allocated to that group. So this group starts from 64. And the first address starts from 0 up to 127, because each customer has 128 addresses. And for the second one, 64.128, which starts from the second customer up to 255, which 128 addresses being given to that customer, 128 addresses being given to that customer, up to for the last one, which is 128th customer, which starts from that address up to that address. So 128 multiplied by 128 is going to be 16,384. And for the third group, we have 128 customers, and each customer needs 64 addresses. It means that log 264 is going to be 6. So 32 minus 6 is going to be n, which is 26. So it starts from that address, and 128 is going to be divided into 4 subblocks, which starts from 0 up to 63, 64 up to 127, and 127 up to 191, and so on. This is going to be the last address and the number. going to be 128 multiplied by 64, which we have 128 customers, and each one is granted 64 different addresses, which is going to be this one. So the total number of the addresses which was given to this ISP was 65,536 addresses, and the addresses allocated to this ISP was 40,000. This one add to the two previous ones, which was this one, and the number of the available addresses is going to be this one. That one minus this one is going to be this one. So this is an example of address allocation and distribution by an ISP. So this ISP has been granted those addresses from 190, 100, 00 up to 190, 100, 255 to 55. So the first group starts from this IP address up to this one. So this is going to be the first address, and this is going to be the last, or the starting address of the last customer, which we have 64 customers. And the second group is going to be granted from this one to that one, and the third group as well as for the third group. And the total available addresses was after this one, or after the end of this one, which is going to be this address 159 to 255. So the next address is going to be 190, 100. After this one, 159 is going to be 160, and starts from 0 up to this one are going to be the available addresses to be allocated to the other devices in the future or stuff like that.